Hello guys, I hope you all are doing good. I am Vaishali Kikan and we are discussing the electronics engineering. Today in this video we are going to move on towards next application of the diode, that is a clamping circuit. The clamping is the next application that we are going to discuss with the help of clamping circuit. The clamping circuit is made of the diode, and diode is a very essential part of the clamping circuit, so we can call it as the next application of the diode. So what is a clamping circuit? So circuit that places either positive or negative peak of the signal at the desired DC level. So let's suppose my signal was from -5 to +5 and I want to clamp the signal, move the signal by a DC level of +5. So now my signal would be from 0 to 10 level, and this thing I can do with the help of clamper circuit. From -5 to 5 I have moved the signal upward from 0 to 10, right? So this is how I can clamp the signal. So clamping circuit adds a DC component to the signal. Initially when I was discussing about -5 to +5, so that time I was having the lesser DC component. Now if I add some DC component, this signal is going to be at upper level, right, from 0 to 10, and this is how after adding a DC component we can get the clamping circuit. So there are two types of clamping circuit, positive clamper and the negative clamper. As the name suggests, the positive clamper is going to clamp the circuit in the positive direction. It is going to add a positive DC voltage. So if my signal was from -10 to 10, we can clamp it to 0 to 20 with the help of the positive clamper. Shape of the signal do not change in this process, only there is a vertical shift in the signal due to the positive clamper, right? So we will be having upward shift in the signal, we will not change the shape of the signal. Now the negative clamper will be having the addition of the negative DC component, which is going to push the signal downwards, right? So I hope you understood the basic difference between the positive and the negative clamper. So clamping does not change the peak to peak value of the signal. So here the peak to peak value was 20, right? So in between 20 my signal was changing, or here also we will be having peak to peak value 20 only, but it is going to change the average value of the waveform. Here the average value is 0, but here the average value will come out to be equal to 10. So you can remember the peak to peak value will remain constant after the clamping, but the average value will change. So this is how we will be having the clamping circuit. So I hope you understood the basics. Now coming to the two types of clamper, we will be having the positive clamper and the negative clamper. So let's suppose this is my input waveform. From -V to V we have the variation in the input waveform. Now here this is the circuit. In the circuit we are having a capacitor C and we have a diode. So now when the diode is placed in the upward direction, we will be having the positive clamping, right? So with the direction of the diode you can see which type of clamping we have. Then we will be placing the load resistance, and from the load resistance we can measure the output voltage. So the output voltage will be clamped, it has moved upside. So from -V to V the duration has become from 0 to 2V. So input signal is a square wave with the time period T, and the clamped output is obtained across the RL, right? At the RL we can measure the output, clamped output. Here we are using the capacitor. So for the capacitor we require a perfect charging and the discharging time, right? We require a proper charging and discharging time. Charging time can be represented as RF into C, where RF is the forward resistance of the diode and C is the capacitance of the capacitor. Now discharging time is equal to tau D. It is RL into C. You can see here RF is very small, forward resistance of the diode is very small, so I can say charging time is very less as compared to the discharging time, because RL I have taken to be very large. So RL is the load resistance which is very large. So condition of operation is that voltage at the diode do not discharge significantly. Now if the voltage do not discharge significantly, we should have a very high discharging time. If the discharging time is very high, the voltage will not get discharged in the very small time where the signal is changing. So discharging will be negligible in this case, and we can consider the discharging time constant to be very high as greater than the charging time constant. So now coming to the clamper operation, how it is going to operate. If I understood one operation, you can understand the second operation. The negative clamper also you can understand really well. So here let's suppose the diode is going to have the negative half cycle of the input. In the negative half cycle of the input, here we will be having the negative voltage, and in the capacitor we will be having the opposite polarity generated. This negative is going to accumulate on this side or this plate of the capacitor, and due to which a positive charge is developed on this plate of the capacitor. Now when I have the positive charge at the capacitor, this is the thing that we are doing with the capacitor. Now when we have the negative side over here, the negative terminal is going to connect to the N side of the diode. So when negative terminal is going to connect to the N side of the diode will be forward biased. So when I am applying the negative half cycle, so this is how the capacitor is going to charge. The diode will be forward biased. It can be replaced as a short circuit. As I told you, the charging time coefficient is very less, so the capacitor is going to charge very fastly, very quickly it is going to charge, right? So now because here we will be having the short circuit, the output voltage, the current will flow through this short circuit only. There would be no current through RL and the output voltage will be equal to 0, right? So now coming to the second case where we have the positive half cycle. When we have the positive half cycle, we will be having the diode to be open circuit. So when the diode is open circuit, no current is going to flow through this diode, and now here I consider the discharging time constant to be very high. So here all of the input voltage was appearing at the capacitor. The capacitor is going to charge very fast with this voltage, right? So at the capacitor I will be having the voltage VI only, right? So here we will be having VI voltage which was developed across the capacitor during the charging. Now this charging time constant is very high, so it is not going to discharge very fast, and this circuit will become open circuit because of reverse bias. And now at RL we will be observing some voltage. So what is the voltage that we are observing at RL? For that we can apply the KVL. So here we have V, here we have V, and here we have the V output, right? VO, right? So V output is in minus sign, and this V and this V are in positive side. For applying the KVL, so V output will be equal to twice of V. So when I was negative half cycle, so that time at the peak of the negative I was getting the 0 volt at the output. At the peak of the positive half cycle I was getting 2 volt as the output. So now here one thing I have considered, that tau D is very high, greater than tau C, and the capacitor is fully charged, is not going to discharge very fast, and input pushes upward by V voltage, right? And now coming to the negative clamper. In the negative clamper what happens? We are pushing the signal downwards, right? So this is the circuit that we have. Now what we have done, what we have changed the direction of the diode. You can see here the direction of the diode is in upside. Now in the negative clamper the direction of the diode will be in downside, right? So again we are supplying a square wave, and we are getting a negative clamped signal. So now the PN terminal of the diode is taken in the reverse direction as compared to the positive clamper. We have just changed the direction of the diode, and again we have considered this condition that the discharging time coefficient is very high as compared to the charging time coefficient. Now coming to the clamper operation, you must have understood the circuit really well. Now coming to the positive half cycle. When I have the positive half cycle, now the capacitor is going to charge by this input voltage only, right? And here the diode will be in forward bias. So when I am supplying the positive voltage over here, you can see the P side is connected to the positive voltage. The diode is going to become in the forward bias, and when the diode is in forward bias, it will be behaving as a perfect conductor, and all of the current is going to pass through it. There would be no current across the RL, and V output will be equal to 0, right? And output is taken across the short circuit, which is V output is equal to 0, or you can see the RL here if we are calculating the voltage at Rn, it is parallel to this short circuit branch. So at this branch I will be having the voltage to be 0, and in this manner also I can represent that the voltage at the output is 0. Now coming to the negative half cycle of the input signal. When I have the negative half cycle, what changes? Only the diode will be behaving as a reverse bias, and it will be behaving as an open circuit. Now we will be having the whole of the input voltage developed across this capacitor. During the charging, the input voltage was developed across the capacitor because the charging time coefficient was very less. It is going to charge very fast. It is going to charge by Vi, right? So now again we can apply the KVL. Here we have minus V minus V out is equal to 0. So V out is equal to minus of 2V, and this is how in the reverse bias we are going to get the minus 2V. So this is how we are going to downward move the signal from the average value 0 to average value minus V, right? So this is the operation of the negative clamper. So I hope you understood both of them really well. If you have any doubt, you can put the doubt in the comment and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. Thank you so much.